Okay, so people had a certain amount of trouble with the special triangles. If you're given the hypotenuse, the long side is root 3 over 2 times the hypotenuse. So x is, in this case, 8 root 5 times root 3 over 2. Well, that's interesting. What does that simplify into? Let's see. The 8 and the 2 cancel into 4. And then root 5 times root 3 is just root 15. So x is 4 root 15, and the short side is half the hypotenuse. And this isn't true for all triangles, and it's certainly not true for the 45-degree triangle. It's only the 30, 60, 90 ones. Half of 8 root 5 is 4 root 5. Okay. So, 2 other notes. If I'm given if you're given the long side, divide by root 3 to get the short side. Okay. What about 45-degree triangles? The hypotenuse is root 2 times the side. Root 2 times root 2 is 2. So A is 4. B, it's 45 degrees. B is the same as the other side. Some of you weren't doing that on the test. That was weird. Okay, so with cosine, let's just take a look. We're starting to sketch. If I want one period of cosine, first of all, I break my y-axis at 2 pi, and then cut it in half to 1 pi, and split those into the 90 degrees. Okay. So first off, a first hash mark that is way longer or way shorter than the others will just get marked wrong. Okay, so cosine is the x coordinate. Cosine doesn't start at 0. Cosine starts at 1. And then cosine of pi over 2, the x coordinate of pi over 2 is 0. So this, unlike sine, this one starts out at a height of 1, goes down to a height of -1. Make sure that those are equally spaced. And to make this not too pointy, come in for a landing, try and aim for like to the left of the dot. And then you can be flattening out as you get to the dot. Again, don't aim for the dot, aim for somewhere just to the left of the dot. I'm going to land gradually, not pointy. Okay, I'm going to graph the following. Tangent is a kind of funny curve. Tangent is undefined at pi over 2 and 0 at pi. So when you draw these, I'm going to space them out equally. What happens is there is an asymptote at pi over 2, a place where it goes way up. Tangent of 0 is 0. I'm going to graph these ones in blue just so that they show up carefully. Tangent of pi over 4, so let me label these. Okay, so tangent of pi over 4 is 1, and then it goes all the way to infinity. So it actually looks like this. Now be careful, I want to draw, if I'm going to draw it to the left, I will need to make it a single hash mark. Now, it's 0 at pi, and the next asymptote is at 3 pi over 2. So notice the asymptotes are, unlike the hash marks, it's not equally spaced. So they're not equally spaced. Second axis has twice as much space as the first one. Okay, so second quadrant up to pi, and then from pi to 3 pi over 2, it does it again. So one period of tangent is just that, then I will continue on. Cosecant, what I'm going to do is 1 over sine. I'm going to graph sine first. Sorry. And I'm going to make it a little less tall. 1 over a number close to 0 is really tall. So if I graph sine, let's see. And I'm going to do it as a dotted line. We know from the project and from the previous notes that sine looks like that. Cosecant is undefined when sine is 0. So cosecant has asymptotes at pi and 2 pi. Okay, so if I look at this, reciprocal of 1 is 1. It goes up, actually on both sides. It makes what I call it cups and caps. So cosecant does what looks kind of like a parabola, except it has asymptotes. It's squished on the sides, and then an upside down one. Secant does the same thing, except it's when cosine, since cosine doesn't go through the origin, if I draw cosine in, let's see, pi over 2 pi, 3 pi over 2, 2 pi. Cosine does this, and secant goes to 0. Secant has asymptotes when cosine crosses the axis. Oh, these are the same asymptotes as tangent. So secant has a graph that looks like this. Well, that's weird. All right, cotangent. One more. Let's see. Cotangent has asymptotes. So notice cotangent cotangent has the same asymptotes as cosecant because they both have dividing by sign, and it's the dividing by 0 that causes the asymptotes. So if I draw cotangent in, cotangent is undefined when tangent is 0, at 0 and pi, for instance. At pi over 2, tangent's undefined, but cotangent is 0. Now, cotangent, since it has to start positive, it actually ends up looking upside down. So, all right, so this is just a beginning look at some of the trig functions. I did ask for the domain and range. Let's see, domain. How do you skip pi over 2 and 3 pi over 2 and stuff?
I'll add multiples of pi over 2.
Well, that's odd. These two, domain x not equal to multiples of pi. Okay, range. How high does it go? How low does it go? The range for tangent and cotangent is all reals.
The slope can be anything, positive or negative.
The range for secant and cosecant is numbers below -1, heights below -1, and heights above +1. No, that was long.